Hello, everyone. Welcome to my YouTube channel. You are with Professor Ejaz. Today, we're going to discuss about a very important topic, chemical properties of alkenes. Dear students, alkenes are more reactive than alkanes, and the reason behind this is that due to the presence of double bond, which requires less energy to break. So it is easy to break double covalent bond as compared to the single covalent bond. So this double covalent bond is easily broken. So that's why generally we can say that the alkenes are more reactive than alkanes. As well as the chemical properties of the alkenes are concerned, alkenes always show addition reaction. Addition reaction is that type of reaction in which the only one product is formed. Alkenes show addition reaction with the different reagents like hydrogen in the presence of nickel as a catalyst, and this reaction is hydrogenation. Alkene also react with the bromine or the aqueous bromine at room temperature, and this is bromination. This reaction can also be used to test the presence of alkenes. Another reaction with steam. This is hydration. It happens in the presence of phosphoric acid as a catalyst, 300 degrees Celsius temperature and 60 to 70 atmospheric pressure. So these are the conditions for hydration. And then hydrogen chloride or hydrogen halide at room temperature. Now, as we have already talked about that the alkenes show addition reactions, you will get one product. Now, if we have the different types of alkenes, like if I have alkene ethene, if it reacts with the hydrogen, so hydrogen can be represented by H2. This hydrogen can easily break the double covalent bond between carbon and carbon. So the conditions are this happens at almost 200 degrees Celsius and in the presence of catalyst nickel. Now, this is an unsaturated compound, hydrogen. When it breaks the double covalent bond between two carbon atom, one hydrogen is attached with this carbon and the second hydrogen with this carbon. So you will get the product like this. So ethene will be converted into ethane. Now, if we have a structure like this is propene. So propene also react with the hydrogen to give a single product. So these are the two carbon atoms which contain double covalent bond. When double covalent bond breaks, one hydrogen can be added with this carbon to make it CH2 and one with this carbon to make CH3. So this is the addition reaction, and the importance of this addition reaction is that unsaturated hydrocarbons can be converted into saturated hydrocarbon. And we can also say that the vegetable oils contain unsaturation. So the vegetable oil contains unsaturations. When hydrogen is added in the presence of nickel catalyst, 200 or 250 degrees Celsius, the margarine will be formed. The next reaction of hydroethene is with bromine. If ethene reacts with the bromine, Again, the double covalent bond between the two carbon, when it breaks, you will get a product like one bromine is attached with this carbon and the second bromine with the second carbon. So you will get 1,2 dibromoethane. This happens at room temperature, and this reaction can also be used just the presence of alkene. Bromine is brown. So if the color of the bromine changes from brown to colorless, that indicates the presence of alkene. So alkene turns bromine from brown to colorless. Now, if we have a compound like this, which is propene, and if it reacts with the bromine, one bromine must be added with this carbon, second bromine with this carbon. So you will get a product like CH3, CHBr, and CH2Br. Now, this is the first carbon, this is the second carbon. So you will get 1,2 dibromopropane. Now, there are three carbon atoms, so that's why this compound is 1,2 dibromopropane. Ethene can also react with steam in the presence of phosphoric acid as a catalyst. Temperature must be 300 degrees Celsius, 60 to 70 atmospheric pressure, or you can say 6,000 kPa at pressure. Now, these are the conditions. Again, the water that can be written like HOH. Now, ethene when reacts, then hydrogen can be added on this carbon and OH group on this carbon. So you will get a product. There were two carbons, so add one more hydrogen to get CH3. Now there are two hydrogens. Then you can add one more hydrogen to get CH3. Two hydrogen on this carbon, then add one more hydrogen. Oh, to add one more OH group, sorry. So CH3, CH2, OH. Now this was ethene and this is ethanol. So same type of reactions can be shown with the different types of alkene if propene. Now this is the propene. If it reacts with steam, now there are two possibilities. Hydrogen either can be added on this carbon and OH on this carbon. So if we add hydrogen on this carbon and OH with this carbon, we will get a product like propane 1-ol. But that can be also like which must be can also be added on this carbon and hydrogen on this carbon. So you may get another product. So these two possibilities are possible, mean you can get the propane 1-ol or propane 2-ol. Let me tell you another example. Now, if you have a compound butene, so if it reacts with the steam like HOH, if you had hydrogen on this carbon and OH on this carbon, you will get a product CH3, CH2, CHOH, CH3. Now, if I add OH on this carbon and hydrogen on this carbon, then we will get a product like CH3, CHOH, then CH2, CH3. Now, if we look at the name of this compound, this is the first carbon, this is the second carbon, third and fourth carbon, there are four carbon. So this compound is butane 2-ol. Now you can name this compound as well. Now the functional group is close to this carbon, so we can start from this side. So this is also butane 2-ol. It means that the butene can give us only one product, which is butane 2-ol. If I change the position of the double bond like CH3, CH2, CH, CH2, now this is but 1ene. And if it reacts with the steam, which can be represented by HOH, HOH means H2O. So this, if we add this hydrogen on this carbon and OH on this carbon, or OH on this carbon and hydrogen on this carbon, we may get two types of the product like CH3, CH2, CH2, CH2OH, and CH3, CH2OH, and then CH2, CH. So this is butane 1-ol, and this is butane 2-ol. This is CH3. It means that if you have a symmetrical alkene, now the double bond is between the two carbon atom, but you have the equal length of carbon on either side. This is the symmetrical alkene, but this is a asymmetrical alkene. You contains three carbon atom on left hand side and just one carbon atom on the right hand side. So if you have a asymmetrical alkene, which can give you more than two products. There is another example. Now, if I have alkene, which is but 1ene, and if it reacts with HCl, now hydrogen can be added here or here, and Cl here. So you will get the two types of the product, which is CH3, CH2, CH2, CH2Cl, or if chlorine is added on this carbon, you will get a product CH3, CH2, CHCl, and CH3. So these are the two possible products when but 1ene reacts with HCl. This is 1-chlorobutane, and this is 2-chlorobutane. So these are the chemical properties of alkene.